Welcome back to DellyMaths Concepts. We're looking at the solutions here for June 2022 CXC paper 2 question. We're going to be looking at question 8, 9, and 10 in this segment. All right, because there was a video that was done already last night looking at all of section 1 from 1 to 7, fully explained. So we're going to be looking at these now. It says, this is number 8, it says a rental company has X cars and Y mini vans. So talking about X cars and Y minivans, it says the company has at least 8 vehicles. So we want to make sure that we circling that at least 8 vehicles altogether. It says the number of minivans is less than or equal to the number of cars. And then another situation says the number of cars is no more than 9. The question follows by saying, write down 3 inequalities in terms of X and Y, or Y and others, other than X greater than or equal to 0 or Y greater than or equal to 0, to represent the information. The first information I'm going to pick on is the first thing that says that the number of vehicles must be at least 8. We want to bear in mind that cars is X and the minivans, we want to make note, minivans is actually Y. Therefore, the number of cars plus the number of minivans must be greater than or equal to 8. And the reason for that is that the company has at least, so it must be greater than or equal to 8. That is the first one. The second inequality came from the fact that we have the number of minivans, which is Y, is going to be less than or equal to the number of cars. Thirdly, we were told that the number of cars is no more. So if it is no more, it has to be less. So X is less than or equal to 9. So it's no more than 9. Those are 3 inequalities that we, picked up from that situation right there. All right, so we have that. So let's move on to the next question. The next question says, a car, so we're saying that the car carried 4 people and the minivan carry 6 people. All right, so car is X, minivan is Y. All right, so they're saying that there are 60 people to be taken on a tour. Show that 2X plus 3Y must be less than or equal to 30. I would use the situation that we have to create our thing first. For example, 4X, which is, we're talking about the number of minivans. It's talking about 4 people per minivan plus 6Y, 6 people per minivan. So 4 people per car, 6 people per minivan must be less than or equal to 60. So we're saying that this, but if we want to show, then if we divide everything by 2, then you could say we could show that because 2 into the 4X is going to give us 2X, 2 into the 6Y is going to give us 3Y, and 2 into the 6 to give us 30. Hence, we would have shown that. So you could have seen that, picked up that mark, and we move on. So definitely now we're looking at 4 inequalities, 3 up there, and this is another situation. All right, the question says, on the grid below, plot the 4 inequalities associated with the inequalities in A and B, shade and label the region that satisfy all 4 inequalities. All right, so we want to label it R. So basically now, for every inequality, there is a line that is associated with it. So I could just drop them at the side here. For the inequality that says X plus Y is greater than or equal to 8. The line associated with that is X plus Y equal 8. So we want to get that line now. I want you to understand that this is as simple as it is. Any X value plus any Y value that gives 8 is a point on the line. So you could just do this right now, You could do this. Some people might just pull up this and do substitution for it, because if x plus y equal 8, then if x is 1, then y must be 7, because we're talking about 1, and you do your working out 7. So 1 plus 7 is 8. So I could plot a point 1, 7. I could plot 7, 1 as well. So so there are so many ways to get 2 points here. I could have 7, 1 as well, because when you add x plus y, you get back to 8. So we are suggesting then we can use various methods to find a point. So that's one of my point there, and that's another of my point, because so the coordinates are so the coordinates are 1, 7 and 7, 1. We have many 0, 8, 8, 0. Any 2x and a y value that adds to give 8 is on that line. So basically then I'm just going to take out my line here and I'm going to extend it, draw a line through that. There it is. All right, so we're going to draw a line, take up the line, have the line. There is a line. So this is the line that says x plus y is equal to 8. All right. Let's go for the next line. There's another line that says where the inequality is, we have y less than, all right, y less than or equal to x. So this is another one, y less than or equal to x. The line associated with this inequality is y equal x. So all we have to do is to just put the equal sign where the inequality is. So definitely y equal x is an idea that says if x is 0, y is 0. If x is 5, y is 5, because y is equal to x. If x is 10, y is 10. So you could pick up any of those that are suggesting that. So we're saying it's going to pass through 0, 0. It's going to pass through 5, 5, 4, 4, stuff like that. So I'm just picking 4, 4 here and 0, 0. And then I'm going to just draw a line through that. I will just draw me a line through that. All right. So here is my line. So I'm just going to draw my line through that. All right, quickly. And normally I love to draw my line off the grid. There it is. Let me fix it. One more second. Right. There is the line for me, y equal x. And you could look on that line, you're seeing where every x value is the same as the y value on that line. So you'll find 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and it goes on. Right. Another inequality that we had was that x must be less than or equal to 9, which means that the line that we're working with is x equal 9. So we want to utilize x equal 9 right there. So we'll take out our thing, going for x equal 9. X equal 9, here it is. It is where 9 is on the x-axis. So we're just going to draw that line like that. And we're going to label it, all right? So I'm going to label it x equal 9. So we're seeing that x is equal to 9. So that's line. So the moment I drop my lines, I label them. There's another line that we need to drop now. And it is the line that is associated with this. It says we could write 2x plus 3y is less than or equal to 30. And it's coming from that same 60 thing. So what we want to do, this is the line, this is the equation though, that is associated with it. We replace the inequality with a equal sign. because an inequality is a region. So let's go for it. We could do some quick substitution here. So we're talking about 2x plus 3y equal 30. I'm going to be using up my zeros. So I'm going to substitute 0. 0 for x. So if 0 for x is 0, all right, 0 for x is there, 30, sorry. So we're suggesting no, this is 3y equal to 30. That means y is equal to 10. So y is equal to 10. So I have a point 0, 10 right there. Also, I'm going to say, what if y is 0? Well, let's do it. 2x plus 3y equal 30. If you're wondering where I get the numbers, I'm picking numbers on my axis and substituting them. But I love to use the 0 first because it works very quickly and, you know, less stress. So if y is 0, check this out. 3 times 0 equals 30. So if y is 0, then we have 2x equal to 30. That means x is 15. So the point here is 15 with 0. So we have a, oh, look at that. We have a 0, 10 and 15, 0. So those are the 2 points that I need to find just to connect that line. So I'm coming from 0, 10. So let us look. See there? We're coming from 0, 10, which is right here. And we're going to 15, 0 right there. So I need to take out my line, yeah. Drop my line right here, yeah. All right, let me go for it. All right, let me take off this. So there is my line. That's my line right there. So that is that line, which is 2x plus 3y is equal to 30. That is the line. So let's blow up our lines. We're looking at them. This is it. All right. Now we want to shade the region. So I'm just going to point in the region. Remember now, for each line, we'll know based on the condition. Remember, we have x is less than. So if I'm focusing on this, x is less than or equal to 9. So it's going to be pointing in that direction. So we're saying, so we want to look at the arrows. So it's pointing in that direction. 2x plus 3y. So if I'm looking at this one, no. 2x plus 3y was less than 30. Less than or equal to 30. So the response is down here, down there, pointing in that direction, pointing in that direction. Let's look on this other one here. This was a x plus y must be greater than or equal to 8. So if greater means above the line, so it's pointing in that direction, pointing in that direction. And then now, lastly, y equal x, it says the number of cars, the minivan must be less than or equal to. Less than or equal to, pointing this way for that line, this way for that, this way for that. So if you really look though, you're seeing the solution region for everybody. I could mark it off from here to here, to here, to here, to here. This is my solution region, and I'm going to put it in yellow. This is the region. All right, so that is my solution region right there. Yeah. And I'm going to put R in it. There it is. So that's the solution region for our inequality there. So we would have done that based on the question, shade and labeled everything that satisfies all. So you could look, you see all the arrows were pointing in that direction. And that is why we had to choose it, because all the arrows were pointing in that area. All right. So there it is. We have that. Let's see the next question that follows, right? So we might have to go back to look depending. So let's see what the question is. It says, it says here, determine the two combination for the minivan, for the minimum number of cars and minivan that can be used to carry exactly 60 people. Right. Want to know that combination that can be used to carry exactly 60 people. So what you want to do, you want to check these, because so we're going to pick up the coordinates. So I highlighted here so quickly to carry exactly 60 people. I can't guess it, but I definitely could say 4 is one, 6 is one, 9 is one, 8 9. These are the places. Those are the coordinates that we're going to be using and to check. So let me write them down here. And we're going to check them. Let me write all of them down there quickly. All right, so let's write them quickly. We're talking about there is a 4 with 4, yeah. There is a 6 with 6, yes. There is a 9 with 4. There is a 9 with a 0, and there is an 8 with a 0. I might not be able to do all, because whenever I find it says determine the two combinations. All right, so that means 2 I'm looking for. I'm just going to try then, all right? So you could remember though that this is X, this is Y, this is X, this is Y, this is X, this is Y. I'm just saying that we want to understand that these are X and Y. And remember, X is for a car, and the car can hold 4 people. Y is for a minivan, and that minivan can hold 6 people. So we're talking about substituting these and quickly see where will we get exactly 60 people. So let us say I'm trying to point 4, 4. It would have been 4 times 4 plus 4 times 6. 16 plus 24. That is 40%. So that's not it. But this 6 times 4, because that's the cars, plus 6 times 6, 24 plus 36, that is 60. That's one of the options that can work. So I need one more, so that can work. So let's go again. 9, 4. Remember, 9 is for X, and then that's 9 times 4 people, and then 4 times 6. 9, 4 is 36. 4, 6 is 24. When I add these, I'm getting 60. And that's another. Therefore, 9, 4 works. Remember that they said 2 combination, and I have found 2. So I'm going to do, no, I don't need to look at anything else. So my combination are as follows. All right, 6, 6, yes, and 9, 4 would be those that will give me exactly 60 people. So I want 6 minivans, 6 cars, 6 minivans, 9 cars, 4 minivans, and that will host the fact that we want to carry exactly 6 people. Let's jump onto the other question. The other question says the company charges $75 to rent a car and $90 to rent the minivan. Show that the minimum, all right, so we want to show that the minimum number of rental costs for this tour, which is this tour, for this tour, that tour, you understand, is 990. So it's not like we're going to search again this tour. So what we're going to do here is to take out our 6, 6, and we're going to work it. All right, remember now it's $75 for the car, and the car is X, and this is Y. So we're talking 6 times 75 plus 6 times $90. We want to work out those values to make sure. So this is $450, 90 times 6. This is $540. So when we add these, I am getting 990 right now, but I'm still going to have to work out this one as well. So we're looking at the other combination. So it's 9 times 75 plus 4 times 90. The 9 times the 75 is going to give me $675. And then this is going to give me 360. So if I add 675 plus 360, I'm going to get $1,035. here it is, that this. But we would have proven that you could see on this that this is the minimum cost right here. That's it. So you just prove. So that is just the proof. All right. Hence, we have proven, right? We have proven that, right? All right. So we have just proven that right there. So we just show, all right? All right. There is a circle theorem question now that we want to look at. Yes, I think I have it right here. So our number 9 is a circle theorem question, and it reads, H, J, K, L, and M are points on the circumference of the circle with center O. MK is a diameter of the circle, and it is parallel to HK. The parallelism is very important to note. MJ equal to JL, and the angle JMK is 38. So they are giving us some information here. What we want to do, though, is to make sure that we are paying attention to details as we go forward. So let us look on this question. It says, explain, giving a reason why angle HJM is 38. So you're telling me already that angle HJM is this angle. I'm going to mark it here. This angle here, all right, I was told that this is 38 by the question. So they're saying just give, because remember though, that they just told us that this line here, look at it, the arrow is on it for parallelism. This line, oh, sorry about that. That line there is parallel to that line there. And then this is a transversal coming on right here. I'm seeing that Z angle coming out. So everybody should see that Z angle looking at that. So yes, it is it, because the Z angles are equal. So this angle here, yes, this angle right here, where the 38 is equal to that angle there, the Z angle. So, all right. So let us just write up that quickly. All right. So it is 38 because alternate angles are equal. Alternate angles, that's the official term. So explain, give a reason why that. I could say alternate angles are equal. So that is a good enough reason to call it that one mark. MJK is 90. MJK, look at it. M to J to K. So we're dealing with M to J to K right here. Remember though that MOK is actually a straight line, which means that we have an angle in a semicircle going on. So the angle in the semicircle going on, I am able to say, oh, this part is 90 degrees based on that fact. So for that one, that angle there that they want at JMJK, it's 90 degrees because of this. Angle in a semicircle is 90 degrees, providing that it's subtended from the endpoints of the diameter, right? Providing that angle subtend from the endpoint of the diameter, which is at M and K, and then it went to the circumference at J. Now, those are the provisions that we are referring to, right? So we have that. All right, let's go deeper. It says determine the value of each of the following angles. Show detailed working where necessary. So we were not asked for reasons, just detailed working where necessary. So MLJ is already highlighted for us. We need this angle right here. We need that angle right there, right? MLJ. So take a good look at MLJ. Taking a good look at MLJ, yes. We're going to notice something here. Let's look at this. This angle is equal to this angle. So if I find this angle, I automatically would have found the angle that I want because they are in the same segment. But I could find that angle now because guess what? Following the triangle M, let me just highlight it again for you. Let me use blue. Following this triangle that I'm going to touch, M, J, We have 90 degrees here, and we have the 38 here. So I can find this here. So simply using 180 minus the sum of the 90 degree plus the 38 degrees. 180 minus 128. All right? Minus 128. And then we're going to be left with 52. All right? So then, make sure. Yeah. It is, but I like to double check. So it's 52, which means that, let me just clear up my diagram here, clear up all of these, clear back up those. Yeah. I am suggesting that this is 52. Therefore, this is 52 as well. So then, that angle down here is 52 degrees. All right, and the working is upward. Angle LJK. LJK. Let's look. LJK. L, where's L? L, J, okay. Oh, it's marked. It's right here. We want that angle there. But you know that if I get this angle here, I automatically get the angle I want because they are in the same segment again. If I get this angle, it is this angle. Same segment. If I get them, I get that right there. So when you look at this, then you're thinking that how can you get that angle right there? How can we get that angle there? LMK. LMK. L to M to K. Because remember, I know we have an isosceles triangle running. So I'm going to highlight the isosceles triangle. You have to be thinking this isosceles triangle will give us a big clue right now. Look at that isosceles triangle. We have isosceles triangle. This side is that side. So the base angles are equal. So with that isosceles triangle, I could tell you that all of this angle here is 52. All of that is 52, like this 52 here. Which means then I'm going to embark on that idea by saying, guess what? I need to say 52 minus 38. If 52 minus 38 is going to give me 14, which means this little piece here is 14 because everything here is 52. And that's the point we're making right there. Let's take off back some stuff, right? So then that is 14. Remember, I just said the moment I find this angle here, then I would have automatically found that this is 14 as well, because they're in the same segment. So when I know that, I ended up knowing that one. So the answer for LJK, we did speak about it up there. That angle here is 14 degrees. And they didn't ask for a reason. All right. But the working out, as you could see, would have just been a 52 minus a 38, getting 14. And then we link the same segment idea. And that's what brought us there. The last one says angle JHM. JHM. Let's go for that. JHM. 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 Let me clear up the diagram a little bit. JHM. Where's it? Oh, JHM. Oh, we want that angle right now. Remember though, opposite angle in a cyclic quadrilateral. So I need to identify this cyclic quad. For us, let me clear up everything that we don't need so that we can see what we need. We don't need any of those. Here's a cyclic quad. I'm going to be putting my cyclic quad in blue. There it is. That. So we're seeing the cyclic quadrilateral. Opposite angles are supplementary. So right now we're able to just manipulate that. 180 minus the 52 and we're done. So opposite angle in a cyclic quad will add to give 180 degrees. So I'll definitely say that 180 minus the 52, and that is going to give us 128. Yes. And then that is the answer for that right there. And we're done with our circle. Wasn't such a bad one, right? Let's jump to number, we're looking at the trigonometry, which is the B part. Let's go. Now we're looking at the B part of it, and it says from a port L, yes, from a port L, shape R is 250 kilometers on a bearing of 65 degrees. So I'm going to mark that for us right now. I like putting on my labels as I go. Here is my 65 degrees, right? And then it says ship T is 180 degrees and you're 180 kilometers, and you're looking at that 180 kilometers and 180 kilometers from L. So we're seeing that. Oh yeah, we're seeing that. And then it says on a bearing of 148, which means that this bearing, all of this bearing here, yeah, from the north, let me from right here, right, from the north, coming around, all of that would be 148 degrees, all of that. All right, this information is illustrated there. So we're looking at that, all right? First question, it says complete the diagram below above by inserting RL. So it's just RLT. Let us look where is RLT. RLT, if I should shade, it's just right here. Right here. Nothing else outside of that. So it's that angle in the triangle there, which means that we have to find RLT by subtracting 65 from 148. So you could see that you will take your 148, take out the 65, and then you're left with this angle in the triangle here that they asked for. So now that we have done that, that's what they wanted to put on. We have that going there. We get one more. Now they're saying using that, we want to calculate RT, the distance between the two ships. So we want to calculate RT, which is, we want to calculate this distance right now. No problem. In calculating this distance, all I'm going to do is to use my cosine rule. Cosine rule says RT squared is equal to 250 squared plus 180 squared minus 2 times 250, yes, times 180, the cosine of 83. Why am I using this? It's because I know everything in that corner. I know the 250, I know the 180, and I know the 83. So when you know everything in that corner and you're finding the side opposite to that corner, then we employ the cosine rule. Now let's carry out our calculations, all right? So in carrying out our calculation, 250 square is gonna give us 62,500, 250 square, yeah? And then 180 square, all right, 180 square is going to give us 32,400, yeah? And then 250 times, so talking minus 2 times 250 times 180, the cosine of 83, that will give us minus 10,968.24. So let's put everything together. RT square is going to equal to, when you add these and subtract, I'm getting 83,931.76. But I like to verify it. So I'm just going to double check it just to make sure that there is no error. Yeah, the principle is right, but making an error will spoil everything there. So 83,931.6, yes. And then I'm going to take the root of that. So the root of that will land me 289.71. All right, 0.71. Definitely kilometers. They didn't ask us to round off anything. So this is basically approximately 290 km. All right, this is basically that R 289.8. So it depends. Any one of those would be a good response right now. Very good. All right, let's go to number 10. So number 10 entitled Vector and Matrices, right? Vector and the matrices. So it says the transformation the transformation matrix, yes. A is equal to 0, -1, 1, 0. It represents a 90 rotation anticlockwise about 0, the center origin. The transformation B is 0, -1, -1, 0, which represents a reflection in the line with the equation y equal negative x. All right, no problem, no problem. All right, now it says write the coordinate of P prime, the image of P, all right, after it undergoes a rotation 90 degrees anticlockwise. 90 degrees anticlockwise, the matrix for that is 0. So this is the A matrix, 0, negative 1, 1, 0. And this is now being used to multiply by 7, 11. So in carrying out our multiplication, it's 0 times 7 plus negative 1 times 11, then 1 times 7 plus 0 times 11. It's the same row by column concept. So what we have is negative 11, I think I'll leave it, this is 7. Negative 11, 7, all right? But the coordinate of the P prime is actually, let's write it properly. The coordinate of P prime has to be written like this, negative 11 with a 7. So we have to be careful how we actually represent what they ask, right? So negative 11, 7, that's for that. Now let's go further. T is a combined transformation of A followed by B. Determine the elements of the matrix representing T. Now, what we want to understand, when we have transformation followed like a combined transformation, it's like we're doing functions here. So we have to be careful how we attack this. It's going to be the B outside and the A inside. This is how we're going to have to. So that transformation is BA. All right. So the one on the inside is the one that is used first, just like when we're doing a composite function, which means then we have to set up the two matrices in such a way that we'll have the B matrix there and the A matrix there. Remember though, that matrix multiplication is not commutative. So if you put the A1 to the left and the B to the right, it's not going to be good for you. All right. Not going to be good for you. So let us write them 0, negative 1, 1, 0. So I'm writing my A matrix 0, negative 1, 1, 0. And then I'm writing my B matrix, which is 0, negative 1, negative 1, 0. So it is 0, negative 1, negative 1, 0. So what I'm saying is this is what we need to multiply row by column. So we're talking about 0 times 0 plus negative 1 times 1. Then we're talking about 0 times negative 1 plus negative 1 times 0. Underneath now, negative 1 times 0 plus 0 times 1. All right. And then we're having negative 1 times negative 1 and plus 0 times 0. So what's my final thing? We have a negative 1. I get 0 there. Get a 0 here again. And I get a positive 1 here this time. So I'm looking at that. So the combined transformation is negative 1, 0, 0, 1. You just multiply ordinary matrix and go. And this is the response for that. So that is the transfer, that is the transformation T, correct? Now, describe geometrically the transformation represented by T. I'll say this to you. What you can do is take a point and then look what happened to it. For example, I'm going to be using, so I'll soon describe it, but let me use it to see what happens. Let's check out a point. Check this out. Let us say I'm using any point. Let's say I'm using a point 7, 11. If I use 7, 11 now, negative 1 times 7, negative 1, let me fix this. Hold on. Negative 1 times 7 plus 0 times 11. And then I'll have 0 times 7 plus 1 times 11. Now let's check this out. I'll end up with negative 7 and 11, which means that my coordinate would have changed from, check this out, it would have changed from a 7, 11 to and negative 7, 11. What transformation would have done this to a point? It kept the x value the same, it kept the y value the same, and changed the sign of the x value. Definitely, this is a reflection in the y-axis. Because when you reflect things in the y-axis, the y value remains and the x value changes its sign. So this is definitely a reflection in the y-axis. And the y-axis is the same thing as x equals 0. Anyhow you want to feel about that. So definitely, that is how you would have approached that. Let's go for more questions. Now, other question says the 2 by 2 matrix C is defined in terms of a scalar constant k. As you could see, C is equal to 3k 64. Determine the value of k given that the matrix C is singular. What's the concept of a singular matrix? The concept of a singular matrix is simply that the determinant of that matrix must be equal to 0, which means that we're going to take the product of the leading diagonal, which is, so let us work out this, the product of the leading diagonal, which is 3 times 4, and I'm going to subtract the product of the non-leading diagonal, yes, which is 6 times k, and this should equal to 0. Let's continue working. 3/4, 12 minus 6k is equal to 0. 12 is equal to 6k. By getting the 6k on that side, we add 6k to both sides. Let me divide by 6, divide by 6. 2 is equal to k. So if k is equal to 2, then we will get a determinant of 0, which means we have a singular matrix right there. There you go. Let's jump into the vector questions. There's nothing sweeter than some vectors, right? It says in the diagram below, O is the origin, OX is U, and OY is V. We're looking at O to Y, O to X. We have those. They gave us those. OX and OY are extended so that X and Y are midpoints of OA and OB. All right. So I'm now told that X is the midpoint of that. So I'm going to put U here, and Y is the midpoint of OB. That means I could put V there. Midpoint is the middle, so I could put the other half on the other side of them. All right. So we have those. I normally label as I go so that the future questions will be a little bit more easier to look at. Now the question says express bx in terms of u and bx. Now let me just drop my bx here so that we could see what we have. We want to express bx right here. Right, so we're dealing with bx right there. So I want to deal with bx going in that direction. Guys, if I want to go from b to x, and I'm on my position vector system here, I am going to be moving from B to O, and then I move from O to X. B to O, I'm going the opposite direction of the arrow that I got, which means it's going to be negative 2V, and then O to X is simply plus U. So that is my response there. That's my quick response to you. Right there, let me fix my V, properly. Hold on. All right, minus 2V plus U, and that is my BX. Let's go for more. Questions are here. It says, given that YA and BX intersect, all right? Given that YA, I want to from this. Let me check if I missed a question. Okay, I did miss. I'm looking if I missed. I think I missed a piece of a bearings question now that I'm thinking. Yeah. All right. We're gonna have to go back to that. I missed a piece of my bearings question. It says, given that YA and BX intersect, at M. All right. So there's an intersection going here. So we're talking about BX and YA. Where's YA? Where's BX? Let's look at YA and BX. So they're saying to us here that YA right that they're saying that YA intersects BX at M. And when it happened, right? When it happened, we're told that BM is equal to 2mx. BM is 2 times that. So BM is going to be 2/3 of the ideal, 2/3 of BX, and mx is just simply 1/3. All right. So now let's see what they want, really. What they want. Let's go back for the question. We want to express BM in terms of U and B. So I want BM, but in order for me to find BM, I need to find BX and then take 2/3 of it. All right. So let's find BX. Now, BX, I could work out BX right here, guys. BX is needed to find BM. So BX is to move from B to O plus from O to X. Did I work out BX already? Why do I feel like I worked out BX already? I have BX. All right, good. So if I have BX already, then 2/3 of BX, all right? 2/3 of BX is BM. So I have it already. 2/3 of BX is BM. All right, let's go. You know what is BM? BM is equal to 2/3 of BX, and BX is -2b plus u. It's 2/3 of it. Let me just re-explain. Because based on the context, when they said M intersect here, it is saying from B to M is 2 times BM. In other words, B to M is twice as big as MX. So we could share it up in a ratio of 1 to 3, 1 to 2, should say, where this is 2 times that idea. So that's what we're talking about. So then I could say that the entire line is in 3 parts and B to M is 2 parts out of the 3. That is why I use 2/3. And then what I'm going to do here with my 2/3, I'm going to distribute it inside. All right, so if I distribute my 2/3 inside, I'll have 2/3 times -2v plus 2/3 times u. We could see this is going to give me -4/3 v plus 2/3 u. This is my BM, just like that. So that's my BM. That is actually -1 1/3, all right? -1 1/3. So I have that. Now that is my BM. Let's go for the next question, because the next question, where is it? Hold on, guys. Okay. All right. The next question, I'm not seeing it here. So it probably fell off. But what the next question actually is, the next question says that given that YA, yes, and BX intersect at M. No. I will do that already. I'm going to have to edit this below. The next part, which is the B part, says using a vector method. Using a vector method. We want to show that the ratio, we want to show this, show that YM to YA is 1 to 3. Show all working bases. We need to show that. Now, all we need to do is to find YA, find YM, right? So we need to find YA, find YM. Now, YM, looking back at what we have there, let's go for YA. If I'm going to find YA, I'm going to move from Y to O, then I'm going to move from O to A. Remember though, YA is -B plus OA is 2U. So there it is. I have my YA. Now I'm going for YM. YM is to move from Y to B, plus I want to move from B to M. Now, Y to B is V. And then I know what BM is. We just did BM right there. So BM is minus 4/3 V plus 2/3 U. Now, when you put this together, and these are the like terms right there. These are the only like terms. That's the only like term right there. So then, what we want to do is to work this out. Let us work this out. Now, let's think about what does -4/3 means. It means -1 and 1/3. That's what it means. So if I have -1 and 1/3 V and a positive 1 V, which is what we just call V, then you could see that we will be left with -1/3 of whatever. So this would have given us -1/3 V leave, because it's like +1 and -1 1/3. When the +1 and the -1 cancel out themselves, we are left with -1/3, and that's what we have there, plus 2/3 U. Now, I want to prove this. Now I have my vectors, they want me to prove, that this is in the ratio of that. You know what that means? You know what that means? That means that YA is 3 times bigger than YM, right? YA is 3 times bigger than YM. That means if I multiply YM, watch this, if I multiply YM by 3, I should get YA. That's what they're saying. So let us try to prove that now, and then we're done. Because this is my YM. So YM is, look at this, YM is -1/3 V plus 2/3 U. Now I'm going to do 3 of it. So it means then I'm going to put the 3 out there and then distribute it now. 3 times -1/3 V plus 3 times 2/3 U. Check this out. This 3 into itself 1 time, into itself 1 time, 3 into itself 1 time, 3 into itself 1 time. So those cancel. What am I left with? I'm left with here a -V and a +2U. This is my proof, because check this out. This is exactly that. Hence, we have proven that. All right? We have proven it. Well, that's the end of the paper. Guys, please like, subscribe to DellyMaths Concepts, because we're doing some serious mathematics here. All right? So share this. All right? And drop some comments and ask whatever you want to ask. I will be responding. See you guys another time. And for those of us doing ad math, look out. The videos are coming out just the same.